Thank you for the presentation. Hello, everybody. So, presentation are done. I'm Michele. Is Lukas? Feel free to ask us any question, not just at the end, but feel free to interrupt us too if you have any question or something is unclear. So we're gonna talk about the content security policy. So we'll first say, what is content security policy? What are its aims? And then we'll inspect a policy. We'll see what's inside a policy. So we'll dissect a policy, we'll see the directives, we'll see what is controlled by each. Then we'll, let's say, wear the breaker hat, and we'll try to break policies. So we'll talk about common mistakes in deploying content security policy. And then we'll talk about bypassing it, maybe not just for a mistake, because of a mistake of somebody, but because maybe something is inherently flawed in the current model. And then we'll try to fix it. We'll present a new way of doing CSP, which in our view is a huge improvement with respect to the current state. And we'll discuss the future of CSP, its limitations, and some success stories. So, what's CSP? So, CSP is a tool that web developers can use to lock down their web applications in many ways. So, it has to be said that it's very important that, to note that CSP is a defense in depth mechanism. This means it is a second layer of defense, and it reduces the harm of malicious markup injection, but it's not to be considered a replacement for actually fixing the bug. So for input validation, or mostly input validation, but also output encoding, right? It's very important. We're talking about a mitigation here. And it is an ambitious project because it has three main aims. So the first one is to mitigate risk. So basically, a web developer has fine-grained control on what its web application can request, embed, and execute. So by resource type, it can reduce the privilege of the application itself. So if you have in mind, for example, the sandbox attribute for iframe in HTML5, well, CSP can be considered like kind of a sandbox attribute for other elements and other resources too. And lastly, but not least, it can be a useful tool for detecting exploitation. So this means that it has a reporting mode where the web administrator is actually notified of violations of such policies. So when the web application is basically behaving in an unexpected way. So sometimes let's say, most of the policies are actually pretty noisy, so they generate a lot of reports. So this monitoring part is not being used enough in our view so far, and so it couldn't be used, for example, for alerting, so for sending alerts in case of exploitation. But it is a part of CSP that is surely worth exploring in the future. So CSP has a lot of directives, and each directive aims to control a different resource type. So for example, image source governs images, font sources, fonts, child SRC, well, frames, but more in general, nested browsing contexts, so also workers. With frame ancestors, for example, you can say, I want my web application to be framed just by some particular origins. With plugin types, you can choose the MIME type of plugins you want to allow to run on your website. So you can say, well, I want to run Flash. Don't do that if you can. But I don't want to run Java, for example. Style for style, and so on. Report URI is for reporting, but we'll focus on script SRC because we want to talk about CSP as a mitigation against cross-site scripting vulnerabilities, which are still the #1 vulnerability in the web. So we'll focus on that. And what is CSP? CSP is an HTTP header. Actually, it's two HTTP headers. Content security policy with dashes. If it is in an enforcing mode, so if it actually blocks the fetch of the resources that are not allowed by the policy, or content security policy report only if it's actually just reporting mode, so it does not actually block the resources that are not allowed, but it still sends a report to the web administrator for later investigation. So let's see a policy in detail. Like, this is a very simple example. So you have on money.example.com, you have an image source cat.png, and you have this content security policy. So default SRC is the catch-all bucket. This means if you don't have a more specific directive that governs your resource type, and you specify a default SRC, then the default SRC governs that. So for example, here we don't specify IMG SRC, so image source. We just specify script source. So this means that images are governed by default SRC. So default SRC, self. Self is a special keyword that means same origin. So allow resources from the same origin. Then we have script SRC, self, and yep.com. This means allow scripts from the same origin and from yep.com. And then you have a report URI for violation. So cat.png is on the same, it's a relative URL, right? It's on the same origin, so it's allowed by CSP. We have script SRC, yep.com, x.js, and it's also allowed by content security policy because we explicitly declared yep.com as allowed in the script SRC directive. But what happens if an attacker injects some markup, like such as this one, you know, the usual getting out of the tag, and then script SRC is sources from his evil domain, attacker.com. That's blocked because attacker.com is a source which is not whitelisted in script SRC, and it sends a report to CSP violation logger, which is the report URI. Same if you just if the attacker just tries to inject a script tag like alert42. It's also blocked because inline scripts are not allowed. So by default, script something and a script are not allowed with unless a very special keyword we'll not talk about too much here, which is called unsafe inline. We talk about it when we talk about fallbacks, but this is an unsafe as the keyword name tells. So this is also blocked and report is sent. I'm going to show you a very quick demo of this, just focusing on the image. So let's specify a policy with image source self. Can you see that? Yeah. And let's load the cat. So the cat loads correctly. But if the applications try to load evil.com cat JPEG as an image, you can see that the browser refused to load the image. It's even before it tries to fetch it, right? It's not fetched because it violates the content security policy IMG SRC self. Okay?
Awesome. Thank you very much for the intro, Miki. So CSP, in theory, is a very promising mitigation technique, right? As we saw, it is probably one of the most promising mitigation techniques for script execution, like preventing unwanted script execution, right? But in practice, it's really hard to deploy at the current state. And so we picked two examples from Twitter and Gmail. But before we were looking at these, I wanted to ask you guys, like, how many of you guys have heard about CSP before? Awesome. How many of you have tried to come up with a CSP for like some application? Cool, cool. So I guess some of you will be like familiar with what you will be seeing now, right? So usually, if you have like a somehow medium-sized application, you will end up with a really long policy. In this screenshots, we actually only have script source directives. It's a bit unreadable, unfortunately, but it doesn't really matter because it's unsecure anyway. But the takeaway is it's very long. It's very hard for the developer to come up with this initial set of whitelisted origins. And at the same time, it's still bypassable, right? Which is very unfortunate. So actually, a lot of policies in the web look like these. We analyzed like 1.6 million policies from the web, and we were able to bypass between 90 and 99%, depends how you count them, right? So this is like significant, right? It really tells us like that the current state is not really working, unfortunately. So we will look into that, why this is the case, and afterwards we'll also look into how we think we can fix this. So, how did we break CSPs, right? First of all, start with some common mistakes. It's like very trivial. Just for the sake of completeness, I'll add it because still it's trivial, but many CSPs break because of this, right? So, and if we say breaking, we mean like in the context of preventing unwanted script execution. So there's still a lot of policies out there which just allow unsafe inline, which basically totally removes the script XSS, whatever protection, right? So an attacker could just inject something like that, like normal attack XSS string, right? It's like if CSP wouldn't be there. Same for default source if there's no object source. So this is trivial, right? Another trivial one, people add schemas as a source like HTTPS, data, or wildcards like star. Again, you can't do inline script, but you can source your script from wherever, right? So it's basically no protection again. So you could, for example, say like source it from attacker.com/evil.js and it will execute again, right? Again, very trivial. Same holds true for object source, by the way. So a little bit less trivial, but we also saw this quite often. For example, people restrict the script SRC, right? Maybe to none or like super restrictive. But then they forget to add default source or object source. So an attacker could just inject the object tag and allow script access, and he will have like full script execution again, right? And maybe even less obvious, self is sometimes a problem as well. It's hard to like verify that automatically because it really depends on what your origin actually is serving. But for example, if your application is hosted on a big domain together with other applications, or if you host user-provided data on your domain, or you have some weird error messages that allow you to echo back strings, right, on your same domain, all of this potentially can be used to completely bypass the CSP as well, right? So for example, if you have user upload, right, you could, for example, include a script file like that from the same domain, same origin. So let's get to the real bypasses, right? Again, this is probably not really new, but it is actually really interesting how many CSP policies we were able to break in the internet because of these errors, right? There's actually like around 75% of Unix CSPs we could find, we could bypass with whitelist bypasses like this and the next one, right? This is actually really significant, like 75% just because of this bug. And the other like 20% were like because of other problems which we have been shown before, right? So how would a bypass look for this? Look like for this instance, right? Like problem is basically JSMP. Whitelisted.com is allowed, and then you have a callback, and the attacker can more or less specify what the JSMP endpoint will echo back to the browser, right? So if we look into, like, if we look at that a bit into detail, right, this is pretty cool. An attacker would source like whitelisted.com/JSMP callback alert1, semicolon. JSMP would say, sure, whitelisted.com is whitelisted, so go ahead. Whitelisted.com will just echo back the callback string, right? And since it's in a script tag, it'll just execute. So that's bad. One could say that usually, or quite often, the char set is restricted for JSMP attacks. Thankfully, it is getting more and more that people actually try to restrict the char set of the JSMP responses. But you could still do something which is called like a sum attack, like same origin method execution. And basically what you can do is you can trigger events, and by that simulate like arbitrary user interaction on the page or other pages. And is almost equivalent to full script execution, right? Because you basically cannot do whatever the user can do. And yeah, so this is definitely bad as well, right? We'll see a demo in a second, but one thing I want to point out, these JSON-P endpoints are not rare, right? They are usually at the CDNs, at like, you know, Twitter, Google, like everywhere where you would put widgets and you would like source them in your application, so you would put them in the whitelist, right? Which is very problematic. Miki will give us a short demo of how this JSON-P attack actually would look like in the browser.
So JSON-P endpoints have a special place in my heart. They are really a useful tool for attackers. They used to be in the past, and they keep giving. As Lukas said, they are really common, so they are still there in most APIs, because a lot of APIs still allow callback something for actually passing data across domains. So there is Course works well, but still we still design APIs with JSON-P, and this is very unfortunate. Basically, what we are saying now is that we can't whitelist CDNs as script sources, which is pretty bad. You can't script ajax.googleapis.com, for example, which is one of the most important CDNs, just because it hosts JSON-P endpoints. So I want to show you Google Maps APIs. Google Maps APIs are sourced from maps.googleapis.com. I hope you can read. Yes. So this is it. So maps.googleapis.com/maps/API.js. Then there is a key, and then there is a callback. So it's still, this is a recent API. So this is dynamic, right? I mean, this is a widget. And still it has a callback, right? So what we can do is we just whitelist maps.googleapis.com, and we now it will pause because init map does not exist. So here, instead of putting init map, I just put alert. And what happens is that alert gets executed. Why? Because this source script, this could be an injection by an attacker, right? An attacker could just see that maps.googleapis.com is allowed, and then what you can do is maps.googleapis.com, then an API, and then it doesn't need to put a key, of course, call back something, right? That would be the beginning of the response. It will be alert, open parenthesis, some data inside. Usually, you can't really put the whole vector like this and then, you know, exfiltrate things. But what you can do is, as Lukas said before, you could create like some gadgets, and you can interact with DOM elements in the page. So you can, for example, if you have an element called X, you can do X click, and it would click. So you can still do a lot of damage. And this is the problem with JSON-P.
Awesome. Thank you very much. Another interesting bypass is just loading an Angular library. Doesn't sound too bad, right? But actually, if you whitelist an origin where Angular is hosted, or even self, when you host Angular yourself, right? An attacker could just load the library, and then when Angular is loaded, he can do whatever Angular can do, right? He can, for example, inject a source Angular expression, do some arithmetics, which is quite boring. So instead, he could do like ng click and do alert like that. Or you could even combine it with other frameworks like Prototype.js, and you could load Angular, then you load Prototype.js, and then you could do like Angular expression on query call, which will give it a window object, and then you would do alert one, right? So at the beginning, you were kind of restricted to the Angular expression context, but Angular has like a sandbox bypass for every version. So you again, it's very likely that you will get full script execution, right? Why does it work? It's very trivial, right? Because whitelisted.com is whitelisted, so CSP will say, yeah, sure, load Angular from whitelisted.com. And then Angular adds an abstraction layer on top of JavaScript, right? It's like a JVM or something like that. And then everything which is happening in Angular, right, in the Angular expressions, CSP doesn't care anymore, right? Because it's not JavaScript, basically, right? So, yeah, that's a big problem. Again, Angular is hosted on most CDNs, right? And which means you put a CDN in the whitelist, you probably will have problems, right? Some of this was taken from Mario's like Q53 mini challenge. There's like a lot more examples like that on the site. It's really I really recommend to go there and check out the examples. It's really awesome. And next is something which is maybe surprising for some of you. It's like a path relaxation attack due to open redirect. So assume you have a policy that is able to whitelist every single JavaScript file, which you will see not very often in practice because it's just extensive, right? You will get a policy like, I don't know, 2 pages long, right? Because and it's changing and sometimes it's dynamic, so you can't really do it. But assume you could whitelist every file in the CSP, right? And assuming you're not whitelisting any JSONP endpoints, right? Let's say Secure has not a JSONP callback. And then you also whitelist some endpoint which has an open redirect. You could do this following. So this would not work, right? CSP would say, nope, whitelisted.com/JSONP is not whitelisted, so it will not load. But an attacker could do the following. He could source it from the open redirect whitelisted origin and let the redirect URL point to the JSONP endpoint, which is also on whitelisted.com, but is not totally secure, .js. And basically what happens is that CSP allows site with redirect.com because it's a whitelist, right? But then when whitelisted.com redirects to, when site with redirect.com redirects to to the JSONP callback, which is also on the whitelisted domain, but not whitelisted, CSP will drop the information of the path, right? CSP will only validate that after the redirect, the domain matches, right? This is something which was added to the spec in response to Homakov's using CSP for evil. He basically was able to read out sensitive data, I think like session token, stuff like that, by using CSP. So they had to fix it in a way that after the redirect, the path is not considered anymore, right? Unfortunately, this makes like whitelists using like full paths much less secure. So TLDR, whitelisted based CSPs are really hard to come up with, to maintain, and they are very often bypassable, which is really bad because CSP has some really great security guarantees if you do it right? So, so CSP is very complex already, right? It has been growing and it is really, really easy to make mistakes if you don't read the spec closely. So we actually are building a tool that shows all the pitfalls, bypasses, deprecated stuff to the developers. So you just paste a CSP and we'll tell you where you have problems, which directives will be ignored in a certain version of CSP, and so forth. So it's not released yet, but hopefully we'll be able to release it soon. Yeah. So as you guys saw, the whitelist-based approach is really hard to make secure. So we and Mike and Arthur and some other folks from Chrome and from other teams actually sat together and tried to figure out how we could improve the situation, right? And we basically came to the conclusion that the whitelist-based approach is kind of broken. So we thought it would be very nice if we could instead just use nonces, right? Nonces have been added in CSP 1.1, but didn't really take off. I think like only 1% of CSPs in the web use nonces. And basically, the script tag in the page is only executed if the nonce value matches the nonce in the CSP header, which is a fresh random nonce for every response. So this should not be guessable by the attacker. A nonce-based CSP is actually awesome because you don't have to come up with the whitelist in the first place. You don't have to maintain it, and you don't have to be scared that your CSP is breaking because your whitelist is not up to date. And most importantly, you won't have this problem with like JSONP and Angular whitelist bypasses because there is no whitelist. So what's the catch? Why isn't not everyone using nonce-based CSPs already? The problem is it's unfortunately not how the web works, right? Most widgets or things you load, right, dynamically source other JavaScript files. For example, like a very popular approach is like module loading, right? You source one file and JavaScript file, and this JavaScript file will like load, I don't know, 4 or 5 other modules, like we'll see in Google Maps. So this usually happens by, document create element script source, module, blah, so it's very often static, and then it's like document body append child as. So the problem is this dynamically created script does not have the nonce, right? So it will not execute, CSP will block it, and your application will break. So what you could do is you could manually propagate this nonce to the dynamically created scripts, but this usually only works if you have like full control of the library, right? If it's your code, you can just propagate the nonce manually. If you use like Google Maps, yeah, well, Google Maps has to introduce this nonce propagation. So it's actually not really working in most applications, unfortunately. And it's hard to refactor that if you're just a developer, right? So we'll show you in a second how we think we can fix that, but very briefly, how do CSP nonces work? We have a policy here with like nonce random in the script tag. The image will still load because the default source is self, and the script nonce random source yep/x.js will also load because the nonce value matches the nonce value of the policy. Sorry. So if an attacker injects an inline script or tries to source a script from somewhere else, it will prevent it from loading, right? Because inline scripts are not allowed if they don't have the nonce, and sourcing scripts is also not allowed if they don't have the correct nonce. And the attacker actually does not know the nonce, right? It's like an XSRF token. The attacker usually does not know the nonce because it's like per response, and the next response will have already been changed and would not work. So maybe a quick demo?
Yes, this will be very quick because I think we have a little more than 10 minutes left. So 12, thanks. Be really quick. So script source nonce random. This means that if you have script nonce random alert 1, it works. But if you don't know the nonce, so you just have a normal injection, this gets blocked. And if you have Google Maps here, you see that it's still blocked. Sorry, Google Maps nonce. Because even if the original JavaScript is allowed, it's trying to load at runtime dynamically common.js, map.js, util.js, stats.js, and these are blocked because there is no nonce propagation method. So a possible solution, what we thought of and what we already propose in the CSP3 specification, is to add a new source expression to script SOC, which we call strict dynamic. The strict dynamic source expression aims to make CSP deployment simpler, and is CSP with this new source expression should work out of the box. So deployment should be much easier and are aimed at web application developers who have a high degree of confidence on what they put in the markup, but low confidence in being able to come up with a reasonable whitelist. And as we showed, I think, extensively before, this is always the case. So basically, strict dynamic is a trust propagation mechanism. So, but it does not apply indiscriminately. So basically, if you have a nonce script and you create a script, you put a source, and then you append child, then it is as if it were nonce to. So this is allowed. But if you have other APIs which are more unsafe, and which is what like technically are called parser inserted, because basically the browser interprets them as if it were markup. So they are, let's say, more free-form styles such as document write or inner HTML, then they're still blocked. This is because these kind of APIs are very dangerous, and this would open up the attack surface unnecessarily. So strict dynamic has two main effects. So the dynamic part, I think, is pretty clear. There is a trust propagation mechanism. You nonce a script. Every script that is dynamically loaded by that script is also blessed and trusted. The strict part is that it drops the whitelist. So even if you have a whitelist, then it is dropped. This is done because most likely your CSP was useless already because you had a whitelist. And we have data, right, to back this up. And also, we want to make CSP backward compatible. So we want to create a single policy that works in all browsers. So browsers, they have a CSP3 compatible. There are CSP3 compatible, there are CSP2 compatible, and then they are CSP1 compatible. So this is the one policy you need to use everywhere. You don't have to whitelist. You don't have to come up with a whitelist. You don't have to maintain a whitelist anymore. So you have to pass a nonce and nonce every script you trust. You have to add the strict dynamic, which is the shiny new thing. And then these two things that might look unsafe, but then we'll show in a second why we put them: unsafe inline and HTTPS. Or HTTP if you are over HTTP. You shouldn't be. So in a CSP3 compatible browser, so with strict dynamic support, basically strict dynamic is respected. Unsafe inline is dropped because there is a nonce. The specification says that if there is a nonce, unsafe inline is ignored. And HTTPS is dropped because it's a whitelist. And as I said, strict dynamic drops the whitelist. So this is basically nonce and dynamic trust propagation. Nothing else allowed. If it is a CSP2 compatible browser, let's say Firefox right now, well, strict dynamic, it doesn't really understand it, so it's ignored. The nonce, well, it has nonce support, so it honors the nonce. It basically drops unsafe inline, but it doesn't drop the whitelist, so you can still, you allow basically every script. So this is a no-op. This is not useful for XSS protection, but it does not break your application. And similarly for CSP1, if you don't have nonce support, basically it's unsafe inline HTTPS. So I'll show very quickly one example. We wanted to be extremely clear about the limitations of this approach. Basically, since there is this trust propagation mechanism, it's very important to note that if you have this kind of vulnerability, which is a very specific vulnerability, basically you have an injection in the source of a document create element script, so in a dynamic script loading DOM API, then strict dynamic is probably not for you. And compared with whitelist-based CSPs, we still think this is a significant reduction of the attack surface. So basically, we are going from being able to bypass the vast majority of content security policy, more than 90%, because of mistakes and whitelist. So CSP was useless for XSS mitigation, in the vast majority of the cases, to having a secure by default. And also, you were basically depending on other you were carrying the burden of other origins you can't control. You don't really know if an origin or a path that you are whitelisting actually has JSON-P or has Angular or has, even open redirects can be a problem. Now, you basically just put trust on what you put. So you have control. You get to control back. You have a secure by default, easy to adopt, with a very low chance of still being bypassable. We also have some data, and this is, of course, not representative of the web, but we did some root cause analysis of the XSS we have at Google, and we found out that this kind of vulnerability, like controlling the URL of dynamic DOM loading, dynamic script loading DOM API is very rare. It's less than 5% of the XSS we know of in Google. So, browser support. Well, Chromium supports strict dynamic already in beta, and we support it in stable by the end of July. And Firefox supports nonces. WebKit browsers like Safari support nonces, even if it's pretty recent. They added nonce support till from like in March of this year. Well, Edge does not have really nonce support, but it's planned. And well, Internet Explorer has a particular view of CSP, and it just honors the sandbox attribute. So I wanted to show you very quickly an example. So you remember before I did script.sc nonce, and then I loaded maps nonced, and there was a problem because it was loading dynamically those scripts, and it was not working. Well, if you just add strict dynamic, it works. Sorry? So
the callback with the alert, you mean, from previously? Yes, but just this one is nonced, right? And the attacker would need to change it, and he does not know the nonce, right? So he cannot use that JSON-P trick again, right?
So basically, an attacker would have to inject a script tag with the correct nonce to add callback use payload, right? And it does not the nonce. So you are protected against that. Yes, absolutely.
Can you repeat his question to the course?
Oh, yeah, sorry. He asked if you, with strict dynamic, you are still vulnerable to, since this is also host a JSON-P endpoint, if you're vulnerable and an attacker could add this payload here in the callback. And you can't because
attacker doesn't know the
nonce, right? Okay, so basically, our point is that strict dynamic makes CSP easier to deploy and more secure. This is not just theoretical. This has been already deployed on several complex Google applications with millions of monthly users, of course. And we proven that it works out of the box, and we implemented that in, it works for widgets out of the box. So we have this test bed down there, and you can check that Google Maps, Facebook, Twitter, CAPTCHA, Google Charts, all the widgets work out of the box. But also, we implemented it in part of Maps, part of Google History, career search. They are very complex and JavaScript-heavy web applications that basically worked out of the box without any refactoring or very limited refactoring. So if you tried in the past to adopt CSP and gave up because all the refactoring was needed, this is much, much easier, and this is much more secure by default. Of course, you still have to get rid, for example, of inline event handlers. Yes, you still have to do that. But you don't have to come up with a whitelist. You don't have to whitelist it. You don't have to maintain it. And so it's a huge relief for developers. So it is both simpler and more secure, which is not something that is, it's pretty rare in the security world. This is implemented in Chrome 52. It's already in beta channel, as I said. It will be in stable probably in 2 weeks or so, but surely by the end of July. And we'd love to have any questions.
I also want to shout out a big thanks to Mike and the Chrome team.
Thanks for presentation, and I have two additions to you. The first one, if someone still doesn't use HTTPS for accessing website, content security policy can help them to implement HTTPS, because if you, for example, can specify HTTPS scheme alone and use as a single header, you can grab a lot of useful information about mixed content. So this is my advice. And the second one is about strict dynamic and formerly known as unsafe dynamic. So what do you think about limitations related to unsafe eval and DOM-based access in this case? So if some website still have to use unsafe eval, and as I think it's a lot of sites still to use unsafe eval, I don't know, for templates in JavaScript or something like that. So if this website have DOM-based XSS and use strict dynamic, so it have some kind of bypass it, because you can inject script and DOM-based XSS, and so if you have paradigm on whitelists, so you have such bypass. So what do you think about it?
Okay, so for the first thing, like detecting mixed content and getting, for example, notifications about mixed content, yes, what you can simply do is default SRC HTTPS, and basically every resource is loaded not over HTTPS, but HTTP triggers a violation, so you will find out even if in very remote parts of your applications you have some load somewhere from HTTP. This still happens, it happens even in major projects, so it's an important point.
Also upgrade insecure requests directive, right?
Right, upgrade insecure request is also very nice, because even if you put HTTP, it asks, you want to ask for the second one? Okay. Yeah, so if you have unsafe eval, well, you don't really have a strict CSP. So unsafe eval usually is not a problem. Most of the times it's not a problem, because it depends on how bad is your code. So if your code, a lot of times you need unsafe eval because of module loading. So there are a lot of bootstrapping code that basically eval constants. If you eval constants, that's fine. And in our experience, this is the vast majority of the cases. We don't have numbers, but
yes. Also, if you would have like a CSP with unsafe eval, and it is like safe otherwise, for example, with nonces, right? You would still reduce the attack surface from reflected and stored XSS to only a subset of DOM XSS that abuses the eval channel, right? So this is still a massive reduction. And yeah, you would need to have a particular bug that abuses it, right?
But yes, I don't want to deflect like the question. Yes, so if you have a non-script and you have any kind of JavaScript code injection in that non-script, which is in, for example, like a DOM script loading API, or alternatively, it is the same, actually it's even more powerful eval, but you have to have like really an eval string plus tainted plus something, yes, that would be executed. It would be executed if you had unsafe eval anyway, because you would have to whitelist, either whitelist or, you know, it's not because of strict dynamic, it would have been a problem even in the old version of CSP.
On your way out, you'll see a green card and a red card in a pile. Please pick one and put it in the bucket so you can evaluate how this talk was. And please, a warm round of applause for such a fantastic talk. Thank you so much.
Thank you a lot. Grazie mille.